Welcome to clickmeproject.com. Let me discuss about the project BRINT, binary rotation invariant and noise tolerant texture classification. Let me discuss about the project BRINT, binary rotation invariant and noise tolerant texture classification. Let us see abstract of this process. In this process, binary rotation invariant and noise tolerant has been proposed, which is very fast, compact and also more accurate, while illumination variations, noise and rotation changes. Texture is a characteristic of all natural surfaces of natural images. Texture recognition process is an important role for image processing. The texture classification problem focuses on the feature extraction of particular image. For feature extraction, local binary pattern approach is commonly used. Binary rotation invariant and noise tolerant approach is proposed, which based on the concept of local binary pattern and completed local binary pattern, that is LBP and CLBP. This proposed algorithm not only provide accurate solution and also performed significantly and consistently better in presence of noise due to its high distinctiveness and robustness. This method used for different level of noise such as Gaussian, salt and pepper and spectral noise. It is highly discriminative, has low computational complexity, is highly robust to noise and rotation, and allows for compactly encoding a number of scales and arbitrarily large circular neighborhoods. These approach overcome the limitations such as the instability of the uniform patterns, the lack of noise robustness, the inability to encode a large number of different local neighborhoods, and incapability to cope with large local neighborhoods with high dimensionality. The texture classification process involves two phases, the learning phase and the recognition phase, which is performed by SVM classifier, that is support vector machine. In the learning phase, the target is to build a model for the texture content of each texture class present in the training data, which generally comprises of images with known class labels. The texture content of the training image is captured with the Gaussian texture analysis method, which yields a set of textural features for each image. In our process, snake texture has been taken and processed. Let us see data flow diagram for our process. There are two phases. This is test phase and this one is train phase. A snake texture has been taken as database images. Read the snake texture image as an input image. In the pre-processing, we are applying Gaussian filtering to our input image. Gaussian filtering is often used to remove the noise from the image. Gaussian smoothing operator performs a weighted average of surrounding pixels based on the Gaussian distribution. Sigma defines the amount of blurring. Large values of sigma will only give large noise. For larger template sizes, noise can be added using the slider. Here, check whether the noise are added or not. If noise is added, then we are going for the feature extraction process. In this, feature selection is the process of selecting a subset of relevant features for use in model construction. Central assumption when using a feature selection technique is that the data contains many redundant or irrelevant features. Feature selection techniques are a subset of the more general field of feature extraction. BRINT has to reduce dimensionality reduction and rotation invariance, discriminative power and noise robustness. BRINT CSM join histogram of BRINT C and BRINT S and BRINT M descriptors has a very high dimensionality reduction technique. In order to reduce the number of bins needed, the BRINT operator assigned a label to every pixel of a gray level images. These all above process are repeated for train phase, where dataset images are trained. Next, in the SVM classifier stage, SVM maps input vectors to a higher dimensionality vector space where an optimal hyperplane is constructed. Among the many hyperplanes available, there is only one hyperplane that maximizes the distance between itself and the nearest data vectors for each category. This hyperplane, which maximizes the margin, is called the optimal separating hyperplane, and the margin is defined as the sum of distances of the hyperplane to the closest training vectors of each category. Uh, in the result stage, we categorize the snake texture based on their names and also with the feature values. After SVM classifier output, finally they recognize the snake texture result based on the SVM classifier output. It's a running procedure for our process. Select main.m file from the current folder, right click that file and run that file. This is the main window for the BRINT texture classification. This is the read image button. It executes for reading the input image from the dataset. Select any one snake texture image from the dataset, and here I display that input image in the axis 1 plot. I am selecting the noise level range. This is the noise image button. Here it executes for adding the noise in the input images. This is the noise image I displayed in the axis 2 plot. This is the BRINT button. We can go to the next window. This is the BRINT feature extraction window. By pressing the BRINT button, we can extract the BRINT feature for our input images. This is the BRINT feature values for the red band. This is for green band. This is for blue band. This is the histogram representation for feature values of red band. This is the feature values for green band, and this is the feature values for blue band. This is the BRINT image representation. Now pressing the next button, we can go to the resultant window. This is the resultant page. Here perform the SVM classifier with the feature values. Now pressing the result button. This is the snake picture name. This is the black mamba snake picture for our input images. This is the classification accuracy graph between existing and proposed system. Conclusion of our process is, finally we extract the BRINT feature for our snake textures and analyze the result with the help of SVM classifier. This proposed approach classified accurately compared with the LBP and LTP feature extraction method. Thank you.